All right, greetings everyone, and welcome to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode we are continuing on with our Python programming series. Joining us back in the studio again today is our programming master that knows all things Python, apparently. His name is Justin Dennis, and Justin, welcome back to the show, sir.
Thank you for having me back here. I'm excited to further dive into Python. Again, though, I think we're holding up this mythos about me that I don't know if I can live up to those expectations.
Go with it, Justin.
But I'll definitely try.
Just go with it, man. Just go with it. That being said, we have covered a lot of ground in Python so far. So if you're just joining us, you might want to jump back and watch the previous episodes. They're going to help you because we've been building a foundation of knowledge so that we can continue to get more and more complexity out of our Python programs. That being said, in today's episode, we're going to cover iteration, and this is probably one of the more difficult things for people to to assimilate into their knowledge base, right? It's a hard concept to grasp. But Justin, I know that if anybody can help us, it's you. You're going to explain what are iterations, how do we use them, and how do we see them inside of Python?
So iterations, you've seen in the previous episodes that we've had ways to do things more and more, one after the other, repeat things. And currently I've just been using the power of my text editor to replicate these things. However, that's unreasonable if we needed to do 100,000 things or 1,000,000 things, which is, a possible request. I need to sift through 100,000 log files to find this particular error, how often it occurred. Or it can be as simple as I need to add the first 1,000 numbers together. It depends on what you want to do. So from the math science perspective, I may need to add up a bunch of things. From a system admin's perspective, I may need to iterate through multiple files, multiple strings, finding instances of like error, something of that nature. And that's really where iteration comes into play. So when I iterate, what do I mean by iterate? Well, iterate, for all intents and purposes, is repeat until some condition is met. And Python has a couple of ways of doing that. I have the for loop, which will be a little later. Those make sense in the context of some other Python structures. And then the while loop. So the while loop can happen anywhere that you can use a for loop, you can use a while loop. They're just constructed a little differently. But what you will find is, if you've ever had something that just keeps asking you for input, I need more information, I need more information. You can even think of it as, someone's like, why? So that's effectively a while loop. That's an infinite while loop. But I can also use that to just keep asking users for information until they decide to quit or some other condition is satisfied. But I think what makes iteration the most difficult for people to grasp is that's not how our brain works. It's not, all right, do this next thing, this next thing, this next thing. If I ask you to add the numbers of 1 through 5 together, you just, you'll write them down and you'll add them together. But if I ask you to do that iteratively, you're like, well, I don't know what that means. So in essence, I would take a container and I would go, if I want to add the numbers 1 through 5, I start with the number 1 and I put it in the container. So I would have like 1 marble. If I wanted to now go on to 2, I would grab 2 marbles, add those in there. 3 marbles, add those in there, all the way up to 5 until that condition's met. And then iteratively, I would have that in my variable, like count or sum or something of that nature. So if you want a nice concrete example of how iteration will work, go find a deck of cards and sort them by suit, and then go 1, 2, 3. So start with the first one, the next one, the next one, the next one. And that's how iteration works. And as far as a general practice, but when would we use it is really where people struggle, or how do we use it effectively?
Well, Justin, I guess that takes us to how we need to start with the foundation. How do we use it? And then you can show us where we can use it in a more practical sense. So let's go there. What you said was there's a couple of ways in which we can do iteration. We have for loops and we have while loops. Which one's the best one to start with? Is there a better one than the other, or is it really just 6 of one, half a dozen of the other?
Ultimately it depends on the context of what you want to do. For loops are great for iterating through a known collection of things. Like I know I have a collection, this group of files that I need to go through. For loops make that incredibly easy. While loops, do you game?
Just a hair.
Just a hair? Yeah, I know some people who game a great deal, and there's actually something called a game loop that is effectively an infinite while loop. While true, always do these things, right? Ask the player to move, move the player, things of that nature. So if I want something to run all of the time, while loops are great. If I want to start at the beginning and go to the end of a collection, then for loops are probably my better choice.
All right. Well, that being said, now that we know kind of where we would use one versus the other, let's do it. Show us how to do one pick. I don't care. Dealer's choice. Whiles or fors, you throw down and show us how we can actually use these things.
All right, so we're going to solve the same problem using a while and a for loop. And we have to, for the for loop, we're going to have to use a new function that gives me a collection. We haven't talked a great deal about collections, but we'll talk about it when we get there. So I would like to, as always, start in the Python shell and just get something working, right? So within the shell, when I have a while loop, I need something to break my, I need something to stop my while loop, because otherwise it'll run forever. And I will warn you, if you accidentally get into an infinite loop that builds up a bunch of memory, you will lock up your computer at times. There are ways to kill processes in Python, Control-Alt-Delete, or I don't know, when in doubt, power button. It has happened to me. It may happen to you. So I like to start just with simple numbers, right? We're going to start just printing out the numbers 1 through 100, right? This is something that seems truly easy, but man, if I had to type print 1, print 2, print 3, print 4, this is very laborious. It's not something I want to do on a regular basis. It's not something that's practical and from a programming standpoint. So I'm going to start from 1 and go to 100. Couple of assumptions. I'm going to represent these as numbers, integers to be specific, and that means that I can use integer operations. So I'm going to start with I equals 1. I is a common convention that people use to represent like a counter. I could just as easily say counter equals 1. And this is probably a better variable name. I wanted to show you that I is sometimes used because you'll see that a lot if you look at other people's code. And I want to say while counter is less. Now here's a new comparison operator. While loops require you to have a Boolean statement. So while counter is less than 100, can I answer that? Can I ask that in the form of a question? Is counter less than 100? Is that a yes/no question? Well, it is. I can say yes it is or no it's not. If the answer is yes, the while will keep running. When the answer becomes no, the while will break or kind of stop. And you'll notice the ... So that means, hey, you're not finished yet. And I'm just going to say print the counter. And now we've just been assigning variables, but when I have numerical variables, I can do things like increment, decrement, divide. I can change their value multiple times. And I think this is where people really get caught up, that it becomes weird, because counter right up here ends up being the same, like it's 1. It is 1 at that point. If I never change that, then counter will always be less than 100, and my while loop will run forever. And as I said, that could be a bad thing. But typically at the end of loops, I want to change that variable because I want to approach a condition where this is no longer true. I want this to become false. So print the number, or counter in this instance, and then when you do, increase it by 1, and then once it gets to this final part, it's actually going to hop back up here and go, hey, is counter still less than 100? Yep. All right, do it again. It's going to hop back up here. Hey, is counter less than 100? Yep, do it again. And it'll do that until it can say, nope, and then it'll jump out.
Yeah, this is definitely, like you said, the portion of our proceedings where people start going, okay, I don't understand what you're doing there. I remember my first time I started looking at loops in general, and you start seeing this idea of is, how does it know that it's gone through the next iteration? How does it know to do this? And it was that incrementation that I was not seeing. And that's what you have to see, is that once we get to that portion where it figures out, okay, I see counter, here's counter's value, and now we compare that with whether or not it is equal to 100. And if it doesn't equal 100, we should do something. What are we doing at that point in time? If it doesn't equal 100, I want you to print this line of text, and then I want you to increment the value of that variable by whatever we put. In this case, Justin's put 1. So now the value of it is 2. It doesn't go back to the original value because we've added that incrementation. It doesn't go all the way back. It only jumps to the while loop or the for loop at that point in time, and then does its incrementation, goes back through it, does its calculation again, and continues to do that until it returns an exit status, which would be, okay, it does equal, or it's less than or greater to, or however we put it in our structure there, to exit out of that piece of code. So to me, Justin, this is the linchpin of how these things actually work, especially when it comes to the while loop.
Yeah, it can take a little bit to get used to, but there's that aha moment that this affords you a great deal of power, because now you can say, all right, I want to look at every file on my computer and look for identifying information, right? This is actually a form of attack, right? I'm just snooping around. But, I don't want to sit there and, okay, I'm going to type all these things. I'm going to say, go through, look at everything. And so let's take a look at how this works. I'm going to run this in the shell, look at a for loop that does the exact same thing, so we can see, hey, these provide the same mechanism, but then we're going to come back and make sure we understand where each part's happening. So if I run this, it goes really fast. But you'll know I don't quite reach 100 because it stops before 100's reached. And whoa, getting too crazy. So it goes 1, 2, 3, 4, 5, and it's just printing that number while it's less than 100. But if I wanted it to actually go fully to 100, I could add an equals to sign there, and we'll actually see that. But how would this look in comparison to a for loop? So a for loop can be used to solve the exact same problem, very simple problem, kind of hokey. So I can say for count in, and then there's a new there's a new function, range, and range can take 1 parameter, 2 parameters, or 3 parameters. We're going to start with a 2 parameter because it's a start and a stop. So I want to get the collection of numbers that start at 1 and go up to 100. So I want for count in range. So for every number in the range 1 to 100, and here's the trick, 100 is, I don't know, is it included, is it not? Because we didn't include it up there because we had some weird logic issues. Let's see what happens. So I click here and I just want to print count. Now count is going to take on the value. It's going to start at the beginning. So 1 would be the first number in that range. And then after it finishes all the for loop, it's going to come back and go, okay, I need to go to the next thing. So I have this is our first exposure to a collection. So this is just a collection of numbers, and we can think of, a range. Okay, 1 to 100, I know all the numbers between 1 and 100. So if we just, doop, and we're done. And that was fast. So notice, simpler than the while loop. And honestly, as a Python programmer, I tend to favor the for loop for most of my things because I know I have a fixed collection that I need to iterate through. But the while loop can come in handy. But we start at 1, go to 2, 3, 4, 5, all the way to 99. So the range function, and the range function here actually is exclusive on this right-hand side. So it does not include the last number that you provided.
So if we wanted 100 here, we'd have to actually make the range 1 to 101, and then you get 1 through 100.
Exactly. So, that's some nice little experiments in the shell, but let's see how we can use that in combination with functions and reevaluate something we've already done using some built-in functionality, but how would that look iteratively? So here we go. Let's kill the shell here. And wow, you got to spell atom correctly.
It does help.
It does help. It does help. So maybe. Oh, I already have it open. I already have it open. So even though I call this while loop, we're actually going to look at the comparison. So if I wanted to embed this functionality and make it general, right? I want to count to any number. And in particular, I just don't want to print it out. I want the sum, right? I gotta sum up all the numbers from 1 to 10. Quick side note, there was a mathematician that apparently figured this out when his teacher gave him some busy work. Find the sum of 1 to 100 without a calculator. Interesting little pattern. But if we have computers, we don't need tricks. We'll just brute force it. And that's where loops come in handy. So let's say find the sum, right, from some number to a second number, right? Now this is where it gets a little weird for people because, again, I just described, I got to think of having a container where I put stuff in it. So I need a variable called sum. And when I start out, I've summed nothing. But I can say, let's start with the while loop. And I need a count variable. And that's actually going to be set to the num, whatever num I pass in. So I'm going to start at whatever this is and go to whatever this is and sum up all of those numbers. So this is getting a little more complex, but we can see we wrap this in a function, and then once we figure out all the functionality within this function construct, we just forget about it.
Yeah, this allows you to be more general and then let the specifics come in at a later time, and that way they can change. The specifics can change, but you continue to use the same block of code over and over again, hence the generality of it.
Exactly. Now this is also a good time to make some decisions. We saw that if we use strictly less than, we don't include the last number. I'm actually going to include the last number, so 1 to 100 with 100 included. Or maybe we'll just do 1 to 10 so we can, I think that's 55, so we can see how that works. So I want to run all the way up to second num, and while we're doing that, I'm going to add to the sum whatever counter is, and I'm going to say counter is increased by 1. Now we saw this plus equals. If you come from a C background, Java background, you may have seen this syntax. This is not allowed in Python. So if you have previous programming experience, you try to do this, it's going to give you an error. And there's a particular reason for that. That little plus plus can go before or after and cause all kinds of problems. So this enforces that counter is incremented after it's used.
Yeah, I've definitely used the plus plus, and I like that, but I see where you're going with it can definitely cause some confusion inside of the program if you don't use it correctly. And it's just too easy for us to make a mistake here, so best to just avoid the mistake altogether by not allowing it.
Exactly. So I think that was a good decision. I have no problem. I've adapted very well. And then at the end of this function, I actually want to return sum. So it's going to spit out some number. And now we've black boxed this function. By the name, find the sum number, another number. I can probably deduce what that's going to do, and then I can just use it without worrying about the implementation of it. So let's go ahead and use that. So let's say x equals find sum from 1 to 10, and then print x. And I've got things all twisted around here. Uh-oh. You know what I forgot to do?
There's your problem.
There's your problem. It happens to the best of us.
I do it all the time. I don't know why. You would think that this would just become like second nature. I'm creating scripts. I'm doing this. I always forget to go in and check that executable. I do not do it. Try to run my script, and it says, "Nope, sorry, that's not a script. You need to give me a valid executable." I'm like, "Oh yeah, I need to make this executable." It's so easy to do.
Yeah, so these are key things that you should check very first. Is it executable? Did I add my shebang? Did I properly, format my syntax? And it'll tell you that pretty quickly. And boom, that was fast. I have the sum from 1 to 100, or 1 to 10. But if I wanted to come back and say from 1 to 11,000, right? Even with a calculator, that would take me 1 plus 2 plus 3. But there it is. And that is the power of iteration. I can do repetitive tasks very, very fast with very little effort. I do want to come back and look at some of the syntax here. I have a function which has the def keyword, and I have this first block of indentation. But you'll notice the indentation for the while actually comes in again saying, hey, this code is associated with this while loop. But this while loop is associated with this function. So I don't have all these curly braces and things, but if I don't indent that properly, and let's just take a look, like let's say that I space, and I didn't indent that properly, it says unexpected indent, and I'm like, huh. And notice sometimes when we start getting these nested ones, I don't actually get the error where I thought I would get the error. So counter plus I think counter's in. Oh, it's actually the line before it. So something to be very careful about.
Yeah, at least it gives you a good idea of about where to start looking. If you see the code there, and as you can see on Jason's example, Jason, I'm going to call you Jason. I told you. It's your new name. It's your new name. In Justin's example, he even though it didn't give him the correct line of where the problem was, it gave him the general whereabouts, and he could start looking and he could see, okay, well, this looks right, so maybe it's something before that. Obviously, it would have to be before that, because once it exits out with an error, it didn't read any of the code below it, if there is any at all, so you have to start working your way backwards, and immediately we saw that indentation didn't look quite right, and you were able to fix it quickly.
Well, Daniel, first off, I have to congratulate you. You've actually already made sense of some of the programming things that we've done on this show. You were like, I know because it's an interpreted language that it doesn't do anything after that, so it stopped there, so that means it had to come before it. So, great job, guy.
I try.
If we can just get that Jason name thing down.
That I'll never get, but...
No. So, I think it would behest us to see how this would look written as a for loop, just for comparative reasons. Now, we're using numbers here just to really drive home the concept. But these really become powerful when I need to automate those tasks, when I need to go through incredibly large collections. Like, for instance, this 11,000 may represent the number of lines in a log document from like my Apache logs or my Nginx logs or whatever it may be. And I can just go line by line and just find, okay, there's an error, there's an error, there's an error. I can do quick error counts. I can actually propagate another file that has just the errors, so I can filter out all the other mess. So even though this is just numbers, this gives us tools that we can use to our, what's the word I'm looking for? To really make us powerful in the programs that we write. So let's quickly look at a comparison between, and you'll find in Python, the for loop is probably the more what they call Pythonic of the loops, because they just work. They just work. So, so for find sum, and I'm going to start with more descriptive numbers. So start and stop, right? Those are probably better variable names instead of num and second num. So for find sum, I'm going to say for element in, so element is something in our collection, in the range of start to stop, and we have to add 1, as we saw. That's not inclusive. And, oh, we forgot something. We need our accumulator. So we're going to have sum again. We're just going to say sum plus equals element and return sum. So if I had to choose between find sum or for find sum, I would choose the for loop version because it's just a little easier to read to me, makes a little more sense. Now I could have chosen variable names that made this a little more, sensible. So if I change this num to, start, and this to stop, then that's a little more readable. So variable names are important. But Daniel, which one would you choose if you had to pick, the implementation?
At this point, I would say the for in Python has definitely seemed to be a little bit easier to follow. So for me, I would probably go with a for loop on this.
Good man, good man. You are following the Pythonic ways. So,
Thank you, Master.
So, we know what 1 through 10 is. Let's make sure that our function runs. Boom, it's 55, just as fast. It doesn't look like there's any issues with how fast it runs in comparison. And if I go all the way up to, 10,000? Let's see how that works. And there we go. What is that? A giant number is what that is.
So lots of 5s and 0s.
Lots of 5s and 0s. But we've now seen both of our iterative structures. These do take a little while to think about. How are these working? We've also seen them in the construct of building functions. But one final thing that I think we may want to see is when would we use maybe these infinite loops that I've talked about. And it provides a final kind of decision-making process in combination with loops that will help us. So I'm going to bring this up here, and I'm just going to forego the functions for now. So while, and I'm just going to say while true, okay? And remind me not to save my text until I'm done talking, because it hops down at the bottom and kind of deletes all of the things that I was trying to do anyway. So real quick, what if I'm taking user input and I'm just asking until, and I give them the option of saying, if you want to quit, type Q, right? Well, I would start with an infinite loop, take user input, use decision-making processes to break the loop only if the input was what I asked them to do. So I would say user input equals raw input. Let's see here. What is a fruit that you like? And then, and here's where it gets kind of tricky. I'm going to zoom out, type Q to quit. So that's a standard kind of prompt you would see, and I just noticed that you may not be able to see me here. There we go. And so while true, take user input, and if someone types Q, I don't want to do anything else. That they said, hey, I want to quit. So if user input equals Q, then I want to break the loop. This is a new keyword. This is saying if you're in the middle of iteration, when you see this word, break out. So if they type Q, I want to quit, else that is a good fruit. Now this is not a robust program, right? I could type anything in here. I could type things that aren't actually fruit in there, like potato. And it would still run. But let's see how this works. So while this is running effectively, take user input with this prompt. If they type a Q, stop. Otherwise, tell them how good of a fruit that is. All right, cool. So, while loops, what's the type of fruit you like?
Let's go with, how about pears?
Pear. That is a good fruit. What's another fruit you like?
Let's go with oranges.
Oranges. I'm going to go with kiwis. And this would actually go on forever. And because I have that pause, it's not eating up a bunch of CPU cycles or a bunch of memory. That raw input causes that to pause so I can gather input. But if I just had this running infinitely with nothing else going on, not taking user input, this would run really, really fast. And you may have to like Control-Alt-Delete or kill the process. But, you know, I want to quit now. I know those are all good fruits, so I type Q. And that's a great way to stop. That's effectively a game loop.
Yeah, and I would assume this is something that they also use in maybe like menu-driven systems, where it gives you a bunch of options. You have to choose a correct option, or if you don't want to choose any of the options, then we need to break out of the loop using something like press Q for quit. I can see that definitely being used in that type of environment.
Actually, old command line style menu-driven applications very much implemented something like this. Application launch, while true, and then there was some decision-making process that, hey, if they want to quit, Alt Q or Alt F4 or something like that. So, yeah.
That would definitely be cool for making something like a systems and networking administration program where you can say, I've got a menu of items that I want it to do. Maybe I want to do some networking tools, or I want to throw in some systems, check the size of my hard drive, how much free space do I have, create a menu, have it call in those functions into the program itself, and when you're done, you press Q, you're out of it. I've done that kind of thing with Bash, and now I feel like I could probably do that with Python as well.
As much as you're progressing over these last few episodes, I have no doubt that you would.
Awesome. Well, we've definitely seen a jump now in our knowledge base as far as Python goes. I feel at this point that we could maybe call ourselves Python programmers. We've definitely got some skills in our toolkit here to be able to create a truly functional, usable type of program. Got a lot of skills in that bag, but I'm sure there's plenty more to go. Maybe we're programmers, but we're not good programmers quite yet. So still a whole lot more to go. But Justin, thank you for indulging us and teaching us how to do these iterations, how to work with for loops, how to work with while loops. They're going to be very, very handy, I'm sure, in our upcoming episodes. That being said, Justin, thank you again for joining us. Thank you guys out there for watching. We're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Justin Dennison.
And we'll see you next time.